What is up, ladies and gentlemen? Welcome back to Unit 3. Now, this unit is where we all died. This is the one that killed us, bro. It was way too much. It's very short. It's very brief. I think that made the test hard. Like, there wasn't a lot of time to actually prepare for the test. So this is one of our lower scores. I didn't draw anything cool. Oh my god, look, I gotta draw something cool. Oh my gosh. But however, it's a very short unit. You can see there's only 3 problems from this unit, and they're beautiful problems for this particular unit. So what I'm going to do here, I'm just going to run through these super fast. Make sure, skip around, slow it down, speed it up, whatever you got to do to stay in tune. All right? I am just going to rip through these 3 problems really quickly because I'm super crunched for time right now. It is now 5 p.m. at the time of recording. All right? I've only messed up like 10 different times, so you know me. You know me. Anyways, without further ado, let me draw something cool real quick. I think I'm going to draw me. I didn't draw anything fascinating, like I usually do. There's my big nose. I think I have some big old lips like this, maybe something like that. I don't know. Is that weird? Should I say that on camera? Maybe not. There's my eyeballs. There's my mustache that I can't get to look right, ever. And then there's my crazy jawline that runs all the way to my ear like this. It looks like a freaking peanut on my head. There's my wicked cheekbone. And I look like Shaggy from Scooby-Doo. All right, that's me, Mr. Shirley Gang. Oh, wait, I didn't draw myself with a hat. No, that's all right. That's all right. That's the Shirley. Okay, now we got something cool in there anyways. So, Unit 3, without further ado. Use the figure. It says using the figure. It means use the figure. What in the grammar? Use the figure to name 2 pairs of each type of angle pairs. 2 pairs of angles, bro? Come on. 2 pairs? We could do that. So, corresponding angles in this picture. Now, this is a transversal. This line that crosses 2 lines is the transversal line. What do you guys think of my bracelet? Gift from one of my students. I don't know if I could say their name on the video, but thank you. You know who you are. You know who you are. All right? Thank you. We got I forgot what I was doing for the bit. Dang. This is a transversal. It crosses 2 other lines. Now, these lines are not parallel. That's okay. Don't panic. They don't need to be parallel, bro. Calm down. All right, calm down. They don't need to be parallel. They can still be corresponding angles. It's just that corresponding angles are equal when the lines are parallel on the transversal. So, corresponding angles here, any angles that are in the same seat. So, like if you're looking over here, and then you avert your eyes to the other side, okay? I see that, if you're looking, 1 is in the top left, number 5 is also in the top left. So, these are corresponding angles because they are in corresponding positions at different points. So, I will say angle 1 and angle 5 for my first pair. All right? Another good one on the inside, baby. We have angle 2 and angle 6. They're both on the top right. All right, so there's my second pair of corresponding angles. If these lines were parallel, then these corresponding angles would be equal. So, for example, if they were like this, you can see that this angle and this angle, which correspond, are probably equal. Like if this one was 40, even though it looks nothing like 40, it's more like 90, but anyways, they would both be 40, right? Anyways, a linear pair, these are any 2 angles next to each other that form a line. So I'm going to give my first set here as 1 and 2. Angles 1 and 2 sit together and make a straight line on the bottom. The other day, a student asked me, why are you allowed to assume these lines are straight? And that is a great question. It's because there are really only 2 clear points in the picture, I guess, is why you can assume these lines are straight. Alrighty? So, we also have, what else do I have? Let's do another linear pair. I'm going to do 5 and 7. 5 and 7 make this line together. So, 5 and 7 are another linear pair. They're not only are they adjacent, they make a line. Okay, vertical angles are across from each other on the intersection. So let me just draw over here. This is the linear pair, something like that. Vertical angles are across from each other. All right. So over here, 1 and 4 are vertical angles. All righty. Now, vertical angles are always equal. It doesn't matter what's parallel or nothing, bro. It's just these two lines. Any two lines that cross, from now till the sun explodes, those angles are equal. All right, and angle 2 also has a vertical angle, angle 3. Those angles are congruent always. We proved this by showing that these angles are supplementary to the same angle, right? They both are supplementary to that angle at top, so they got to be the same. So, same side interior. Now, when I'm reading this, I see same side, so that's talking about which side of the transversal they're on. And then this says interior. This is the other lines. So over here, I need lines that are on the interior, so I'm shading the inside, interior of the two lines, but on the same side of the transversal. So maybe they're like both on the top, or they're both on the bottom or something. So in this case, 2 and 5 are both on the top of the transversal line, and they're on the inside of the other line, so 2 and 5 are valid choices. On the other side of the line, both on the bottom, we have 4 and 7, who also go together. So those are my two same side interior angles, and whenever lines are parallel, these angles are supplementary. Alrighty? Whenever these lines are parallel, they are congruent. Alright? Alternate interior angles are on alternating sides, so let me draw like 2 arrows, alternating sides of the transversal, and on the inside. Alrighty? So there's the inside. Alrighty? So here, 2 and 7 alternate. One's on the top, one is on the bottom, but they're both on the interior. So angle 2 and angle 7 are alternate interior angles. A hint here I gave you guys was to look for the Z. All right? Anytime there's a Z, those are the alternate interior angles in action. All right? The other pair of alternate interior angles are obviously 4 and, well, maybe not obviously, but also 4 and 5. 4 here is on the bottom, 5 is on the top, so they alternate, and they're both on the inside. And then same thing here for alternate exterior, 1 and 8 being good examples. Angle 1 and angle 8, which are on the outside, the outside of these parallel lines, of these transversal lines. Excuse me. I should say these skewed lines. On the outside of these skewed lines, but on alternating sides of the transversal line. And then the same thing is true for angles 3 and 6. See, guys, it's easy. It's so free. It's so free, Mr. Shirley. It's so free. All right? If the lines P and M are parallel, find the value of X. So down here, I see that P and M are parallel. So I'm going to mark that with 2 little arrows to remind me in my picture. Like, these guys are parallel. It's me using this fact, right? I want to find the value of X if this is true. Well, we know a ton about parallel lines. Namely, we know that this angle and this angle are corresponding. And since these lines are parallel, corresponding angles are equal. Since 2x and 50 add together to make this total angle, we can conclude they must be equal to 5x minus 16. Alrighty, so I'll subtract 2x from both sides, add 16 to both sides to get that 66 is equal to 3x, and so x must be 22. There we go. That is my value for x here. And we got one more little goofy problem, and then we'll be done right in, 12, 13 minutes. PSQR are parallel. So this guy starts out by saying these guys are parallel. If you don't know yet, this is the trapezoid. We'll learn about them later. Alrighty. These guys are parallel. And it wants us to find the measure of angle RSP. RSP. I guess this is S over here. It looks like it was cut off by the hole puncher. That's all right. There's S over here. So to find the measure of RSP, we're going to need to know the value of X. If we knew the value of X, we could plug it in and solve. But to know the value of X, I could add up the interior angles of all these triangles and set them equal to 180. So I'm going to try that. Here I have 8y minus 13 plus 3x. That's this guy. plus 2x plus 1 is equal to 180. We know that the interior angle sum of any triangle is 180 degrees, so this must be true. But there's a problem. If you guys remember from Algebra 1, the degrees of freedom. Notice here, I have two variables. I have an x and I have a y. Now, there's a bunch of ways to go about this. One thing that students often do is simplify this to y equals something. And that is A-OK, absolutely A-OK. I'm actually going to solve for x to make it easier on me later. I'm actually going to solve for x, okay? I'm only doing this to keep the problem short and simple. There are a million ways to do it. Please don't feel like the way you're thinking of doing it is wrong. Alrighty? I encourage you to try it. See if you get the same thing that I do. Okay? I'm first going to simplify and solve for x. So I'm going to begin by combining my like terms. I have an 8y, which is unique. There are no terms like 8y. I have a 13 and a 1, which gets negative 12. And I have a 3 and 2x, which makes 5x, which is equal to 180. And now I'm going to move everything that is not an x, I'm going to move it over to the other side because I don't want to deal with it anymore. 5x is equal to, and I'm adding 12, so I should get 192 here for my 180. And then I'm going to subtract 8y. All right? And now I could divide everything by 5. I think I'm going to do that just to keep it simple. I want 1/5 of the other side. I'm dividing everything by 5 there. And now the problem is I can't solve this. Even though I have x alone, I still have a y value. If I could just get rid of this y, I could solve for x and be done because I'm plugging this in. I'm only solving for x so I can get a value for s. All right? So here's part 2. I also notice that, and like whenever, let's say you were stuck here. Let's say you were doing this problem, you got stuck here. Mr. Shirley, what do I do? Well, I ask you, what have you done? If you want to know what to do, ask yourself, what have you done? Okay, so in this problem, I've set up something, but I haven't used the fact that PS and QR are parallel to justify anything. Alrighty, so maybe that's my next step. Here I see that QR and PS being parallel means that this angle and this angle are the elbows of a Z. Do you guys see the Z? So they are alternate interior angles, and they must be congruent since those lines are parallel. So this means that 5y plus 14 must be the same as 8y minus 13. Ah, look at that. So I'm going to add 13 to both sides, subtract 5 from both sides to get, let's see here, 27 is equal to 3y. And so y must be 9. And now that I know y is 9, I can plug it in for x. This means that x is equal to, so I'm going to back substitute 1/5, 192 minus 8 times 9, which is equal to, and I don't know what that is. That's crazy. That's when you ask the calculator, bro. So in the calculator real quick, see if you guys can see it. Is that, yes, okay, beautiful. So I'm going to do exactly, I'm going to show you guys how to type it in exactly how it reads. I'm going to hit alpha, and then I have a fraction bar, 1/5. There's a parenthesis, then I wrote 192 minus 8 times parenthesis 9, and then I had to close both my parentheses there. Look, there's 2 parentheses at the end. Enter. And it is 24. Look at that. So I get 24 here for the value of x. But I'm not done. I can now use this to say that 2 times, I could say the angle S, I guess, is equal to 2 times 24 plus 1, which is, of course, 49. Yeah, wait, what? That's cool. It's 49. Interesting. All right, so that is my answer here for this last problem. If you guys are confused about my method, essentially, if we just walk back through what I did here, I wanted to get S, so to get S, I needed X. But to get X, I needed Y. So it ended up being a 3-step problem. I had to find Y, then use that value to get X, then use that value to get the measure of angle S. So this was my game plan. There are a billion ways to do this problem. You do not have to do it this way. You could have started by seeing that these y's were equal and getting y first. You could have started by using some other method to add these triangles' angles together. You could have noticed that there's an exterior angle somewhere and done something there, right? There's all kinds of stuff you can do. This is just one way, what I believe to be the shortest way that fits on the paper nicely. That's why I picked it. Ready? Not because one way is like better than the other objectively. Okay, anyways, that is all I have for Unit 3. Unit 4, I'm going to do it in 2 parts, first 2 videos.